is going to be the video for page 10 and 11 in your ISN. You can get the notes and finish any of the problems that I don't finish for you in these two pages, rational numbers, and then rational numbers with fractions to decimals, decimals to fractions. Page 10 and 11, if your ISNs are put together, these are the pages if they're not. Rational numbers, this is a definition. It is a fraction. It is anything you can write as a fraction. So all of these examples, they write them as fractions. 1.5, that can be written as a fraction. Any whole numbers, you can write those as a fraction when you write them over 1. Even repeating decimals, 1/3 is the same as a rational number. So when you're looking at page 10 in your book, your ISN, you can start writing these notes because we know a rational number is a fraction. So what this shows us, these are called sets and subsets or of number systems. The very first number system that we ever learned was a natural. It's the counting numbers. It starts at 1, 2, 3, and then you got to kindergarten and got all the way to 100, and then you could keep going. Those are counting numbers. Any positive whole number is a counting number. The whole number is a bigger, or this set is a little bit bigger because then they added 0. So whole numbers are all the counting numbers, all the natural numbers plus 0. The next set is integers. Those are all those positive and negative whole numbers, or sorry, all those positive whole numbers and the negative ones. So now you have a bigger set that we've learned, and it includes -3 and -212 and +212 because it is all of the naturals, all 0, and all those negative numbers that are whole numbers that do not have a decimal. Now, rational numbers, this set got a little bit bigger because we added all the fractions. It could be a terminating decimal, like you saw in the example, or 1/2. Our favorite, of course, was 0.5. That's it terminates, it ends. Or it could be a repeating decimal, like 1/3 they showed you. And remember, we can write this as 0.3 with a line over the numbers that are repeating. So these are number sets. Rational number is a set, and these are subsets of the rational numbers. And you can see how they just include, they got bigger and bigger. On page 11, we're going to do a little more formal definition. If you need to pause and get these notes down, do that. But a rational number is any number that can be written in the form of a fraction. So they write it as A over B. Here's a big idea here, though. B can't be 0. There's a few things in math we cannot do, and one of them is dividing by 0. You can't take a group of numbers and put them nowhere, divide them into nothing. So that's the definition of a rational number. Make sure you get that down. Here's some examples. We'll talk more about numbers that aren't rational. They're called irrational, but of course our favorite is pi, 3.141. And here is what rational numbers include. Terminating decimals, decimals that end finite, that means they finish, or decimals that repeat, they go on indefinitely. So make sure you get these notes. And then I'm going to help you with the fractions to decimals and decimals to fractions. Writing a fraction as a decimal, what we need to remember is we now write fractions instead of writing the divide sign. We used to say divide, and now we're going to, make that go away. We used to say 1 divided by 5. Then what we're going to say is, and I lost my pen, so I'm going to go back and see if I can find it. We said 1 divided by 5. Oh, and then we did long division. And we said, oh, how many times does 5 go into 1? Or we now know it's a fraction. It is the numerator divided by the denominator. So when we do this division, we can actually see that 1/5 is the same as a terminating decimal, 0.2. To change fractions to decimals, we are dividing numerator divided by the denominator. When we write each decimal as a fraction, this one, when we have a terminating decimal, we have to look at the last non-digit number and its place value. So the 5 is in the hundredths. That means this is 65 hundredths, or 65 over 100. This is the exact same as 0.65 as a decimal. Probably the answer, you will reduce this, right? Because it has a common factor of 5. So you could divide the numerator and the bottom denominator by 5. Look at the place value in this example. The last place value is in the thousandths. So this is going to be 825 thousandths. And you would reduce that, but that's how we're going to write a decimal, a terminating decimal, as a fraction. This last one's a little trickier when you have a repeating decimal. So I'm going to show you the math, then I'll tell you the trick. We're going to let x equal the repeating part. So you can see what I said here. X is equal to 0.7. This is an equation. When I have an equation, what we have always told you is what you do to one side, you can do to the other. So I can let 10x equal 7.7 repeating. I'm going to multiply both sides by 10. I multiplied the x and the repeating part by 10. Okay? So now what I'm going to do is I'm going to get rid of the repeating part. I am going to subtract x from the left-hand side. So I'm going to subtract 0.7 repeating from the right-hand side because that's equal. So I'm going to make the repeating stuff go away. So I have 9 x's on the left, and I actually just put 7 on the right. Well, if I'm solving this equation, I'm going to divide both sides by 9. Do you like how I'm showing my work? So actually, I can write the repeating decimal 7 or 0.7777 as 7/9. Try it on your calculator. Try 7 divided by 9, and you're going to get 0.7 repeating. I'm going to show you one more time because this time I have two numbers that are repeating. So if I have x equaling the repeating stuff, I'm going to multiply because there are two numbers. I'm going to multiply by the 100, both sides. So I get 100x equals 48 plus all that repeating stuff, 0.484848. I am going to get rid of the repeating by subtracting the 0.48 repeating from both sides, or subtracting x. 99x is equal to 48. Oops, I lost my x. 48, because I got rid of all the repeating. So my x as a fraction, 48, I'm going to divide both sides by 99. So when you try that on your calculator, 0.48 is the same as 48 over 99. If you have a repeating number, decimal, you're going to put it over a 9. So 0.5, right? To write that as a fraction is actually 5/9. Instead of writing it as 5 over 10, I'm going to write it as 5 over 9 when it's repeated. Try it on your calculator. Make sure if you have 0.32 repeating, so 323232, the fraction equivalent is 32 over 99. Okay, make sure you can do that. Make sure you finish all the stuff that you were doing in your notes, and that's the rational number system. I'm all done.